Alright, should be streaming as far as I know, or care, or understand. So it'll be just a moment. I'll be with you on the subject again of gravity, using a Veritasium video as evidence of really completely unevidenced theory of conventional physics. It's a gigantic leap and stretch and perversion of reality. You could say it's extraordinary claims that they're making, and they don't even have any ordinary evidence. And there's a whole bunch of counter evidence they just avoid dealing with. So there's so many truths about gravity that make it unacceptable to pretend that it has something to do with some notion of relativity. You know, how that somehow makes it possible to escape all the rules of regular physics, conservation of energy and such, and they just ignore all of the defects in their theory. So they just play a game where, yes, any other theory has a defect, they will exploit it. Their own theories have defects, they will ignore it and do it aggressively. Yes, aggressively ignore the defects. So, this is like 4 years old, I believe, but it's completely consistent with his videos of the last 4 years, where he makes a bunch of extraordinary claims based on very thin and weak evidence chain that he perverts and funnels and controls. So let's only include the facts that are for our theory, and let's ignore all the facts. And there are extensive facts that destroy and make it ridiculous. So I will make their theory ridiculous. Okay, I'll reveal how ridiculous it is. That's what I'll do. Alright, so with that, I guess we don't bother showing you how gravity works, but maybe a little bit. Can't hurt. It's simple enough. There's an event that takes place that wouldn't happen if gravity didn't exist. So you have some kind of gravitational body, and what you're going to have is that some other body is now going to have a collision. So they can pretend this is moving or this is moving. It doesn't matter. The collision doesn't happen if there's no gravity. So we know that the bent geodesic, whatever it is causing a collision. And obviously when there's a collision, somebody has to be moving. So let's not have an argument about it. I mean, it's obvious the little thing, because the whole universe isn't moving. So we do have a frame of reference. I mean, we do have a frame of information. So they always narrow the box. So what they do is they set up a situation and say, you can't tell. Well, of course, unless you look out the window and see that the rest of the universe is doing something. So obviously, it's their nonsensical notion that to the observer, right, it's quite obvious the universe is staying still and they're moving. And they're supposed to assume that it's quite possible that the whole universe is moving and they're standing still. And obviously, that sounds ridiculous. And it's almost a thought crime to imagine that just for you, the whole universe decided to move, to give you the illusion that you were standing still or moving when you weren't. I mean, too ridiculous. So anyway, it causes an interaction, okay? And the interaction isn't just, nothing. It's in a something event, and what it's going to have is an event. It's going to release energy. So the impact alone is clearly creating energy. There's energy that wouldn't exist. The bent geodesic causes the interaction. The interaction is energetic, full of force that's going to be released and sent into the universe. Okay, so we have free energy now based on the bent geodesic. And then on top of that, when the object's all broken and the pieces are just sitting on the earth, well, guess what? They're still at 9.8 meters per second, per 1 second, by the way, 1 second, still pushing on the earth. Okay, they're creating intense pressure. And what happens with pressure? Well, it has to go somewhere. So, there's a clear illustration that I could take 2 Newton's cradle type steel balls, and I could just bang them into each other. And then if I let them reflect, no harm, no foul. But if I push them together and I don't allow them to reflect, all right, what happens is they create a tremendous amount of heat. They can burn a piece of paper. All right, so that's the fact. So it's an energy event, and you always have to account for it. So it either leaves with the objects or it has to leave as heat. It has to leave some other way. So clearly all of this pressure has to leave somewhere. The fact that it, there's an equal amount coming from this side and an equal amount coming from this side, well, as the Newton cradle proves, that doesn't mean it cancels. It means it has to be dispersed as something else. Heat, some other little thing moving, some radiation. So clearly gravity is creating a tremendous amount of heat, and that's why the Earth is molten inside. I mean, come on, it's obvious that's what's causing the pressure, and the pressure's causing the heat. And if I turn gravity off in an instant, every physicist will agree the Earth flies apart. Okay, like catastrophically and intensely. It doesn't just fall apart, it flies apart because of the intense pressure on the inside. So we know gravity's causing the pressure and it's creating heat in the universe. So then he'll make another video completely the opposite of this one, saying that somehow the universe is falling apart and it's all entropy and it's all going to die of a heat death, when his own gravitational theory is generating free heat, because the bent geodesic, again, didn't give this energy from the force. He's saying this object crashed into the Earth and there wasn't any force that made it happen. Okay, so that's their extraordinary claim, okay, that you can generate free heat, a lot of it, all right, in the universe. And you don't have to get it from somewhere. Something doesn't have to cause the motion. The Descartesian notion that you can follow energy throughout the whole universe, that every motion has force, and that force can be traced. A history that goes billions of years, billions and billions of years, because it's conserved. It can't be destroyed. The motion in the universe can't die. And so the only way this moves into that is the motion in the universe had to do it. The heat in the universe did it. The simple answer. To give you the answer to the test later, the heat done it. Okay. Alright, so that'll be enough of a preface. So let's play this. It's just a steaming pile of propaganda garbage. No doubt played in schoolrooms all over the place. No doubt, 14 million views or whatever it is. Just a horrible piece of abstract religious rubbish. And it's just sad and tragic that 99% of people, well, no, 99.99% of people, or 999% of people, are just too ignorant and dupey to recognize when they're being shammed and shenaniganed by pretty pictures and fancy verbiage. But it's just plain poison. Neuron poison. This is just, you might as well just throw brains in the garbage if this is what you're going to feed them. The shortest astronaut ever.
This video was sponsored by Caseta by...
Oh, everybody's just so fucking interested, aren't they? Caseta by Boogaroogie. Two words I'd have no idea what the fuck they could possibly be selling.
Lutron.
Lutron. Yeah, that's a great name for a company. I wonder what kind of shammy, spammy crap they're selling. So all the money, they have the money to waste on all these CGI and other effects, blah, 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 just to do propaganda.
According to the general theory of relativity, gravity is not a force.
Why is this stupid text on my screen? Play spacebar. I don't need to tell me to play. I know that's the play button, okay? I can figure that out, you bastards.
There are no gravitational fields. Gravity is kind of an illusion. And in this video, I will prove it to you.
Okay, so you obviously can't prove it's an illusion because the collision is real. The energy of the collision is real. And that he just ignores. I mean, he has his little fake auto self, his anti, his anti-Veritasium is in the video. And he points out that, well, there is a collision, and he just ignores it. Yeah, it doesn't respond to that fact in any reasonable way.
By blasting off into outer space. In 3, 2, 1...
So, nice visual effect. Okay, you have to give that to these people. But that's it. And so you can see the rest of the universe in the background is moving. And so, again, and he has a window in the spaceship. But he's going to argue that I'm going to do all these experiments in the spaceship and just pretend I can't look out the window and see that the rest of the universe is moving. And I can be damn sure that's the illusion. Because I'm the one moving.
Albert Einstein said the happiest thought of his life was imagining a man falling off the roof of a house.
Right. He also said spooky action. And then his own theory is spooky action. I mean, how do you get more spooky action? Some sort of non-force that gives things, that creates an energy event, but somehow doesn't use old energy that's already in the universe. It uses some sort of new energy that generates out of nowhere. Yeah, that's spooky action. Okay, it doesn't even have to be at a distance. It's just plain spooky, wooey action. So Einstein was a bit of a duplicitous hypocrite. He really, it's pretty pitiful.
What made Einstein so happy about this wasn't Schadenfreude. It was the realization.
Yeah, it's probably his own mansion roof. So he's got millions of dollars. He's gotten paid to spew this garbage. And his research team can't even do any reasonable research. I mean, the things he says about what happened in history are just plain wrong.
That this man, while he was falling, wouldn't feel his own weight.
Right, so that's the magic of gravity, is that somehow this thing called gravity moves us in such a way that it doesn't push more on one surface than the other. So it has a definite direction. It's acting like it's a rain or a river or a wind, but it doesn't hit our surface. That somehow it goes through us and it moves all the pieces exactly the same and proportional to their mass. So none of your senses can detect it because it doesn't push on anything and move one part and not move the other. So you can't detect your acceleration or motion because nothing's moving unevenly. Everything gets pushed exactly the same speed, gets exactly the same force. And so it's collecting the rain as if each little atom was a bucket, and the bucket is the size of their mass. So if you have a big mass, you collect a lot of rain. You have a small mass, you collect a little bit of rain, but you all fall at the same rate. You're all pushed at the same rate. So yes, that creates a little bit of a curiosity because, if I shine bright light at you, I burn your skin. Now, if I shoot x-rays at you, yeah, it goes through you, but it's also doing some damage. But it does, in fact, go through you. So you can understand that these forces, like radio waves, will go right through you. So you can understand that depending on the frequency, depending on what it's doing, it can penetrate, as if it just goes right through you, and it maybe only hits little pieces. And so the argument would be, I would make the argument that gravity is really a proton force. So it's only hitting nucleuses. So it's moving your nucleuses. But the point is it's moving them all proportional, because every proton is exactly the same bucket. And every proton collects exactly the same amount of force, because they're all connected to each other in the end.
He would be weightless. And anything he dropped on his way down, well, it would remain stationary relative.
So we know as he's falling, he's accelerating. So they're not showing that in the image, but he's going faster and faster and faster. Every second, 9.8 increase. So he's going faster and faster and faster and faster. And obviously he's collecting something, because proportional to how much time, how many units of 9.8 he collected, proportional, exactly proportional to that, will be the impact in the Earth. That's just a fact.
To him, or moving in uniform motion.
Jack shit.
So that's all they're saying really is, oh, this is too mysterious that you have this force that is capable of moving everything at exactly the same speed based on its mass. So that's sort of a giveaway, that instead of the sail being made out of cloth, the sail that you're catching the wind with is made out of mass. So it doesn't matter how your mass is shaped, it just matters how much do you have, and that'll decide how much force you collect, because you're really collecting it with protons. It just matters how many protons do you have, and that'll tell you how much force you collect. You'll just have to listen to the commercials, I guess.
Really supports Donald Trump.
I can at least moot them. Yes, whatever. Creeps and, craps and creeps, giant douches and shit sandwiches.
Would be just like
If you were in deep space, not near any large masses, with your spaceship at rest or coasting along at constant velocity.
here.
So again, now the comparison is being made that obviously if I can't feel the force, then yes, it'll be just like standing still, because I can't feel it, because it doesn't move anything unevenly. So you only feel something that penetrates, that disrupts in some way that this tissue next to it isn't being disrupted. So if all of the tissues are moving exactly the same, then yes, there's no relative difference, and that's the only thing your body can detect is a relative difference. So that's why you don't feel the gravity, and that's why it's essentially going to feel the same as standing still, is because you just don't feel gravity. And so when you're hit the earth and the earth pushes just on your feet and it breaks your legs and crushes your spine and does all this stuff, you'll feel all of that because it's a very uneven application of the pressure. The pressure isn't being applied to every proton in your body. No, it's being applied to one section of your body first, and it's being applied entirely to that section. And that's the problem. So it's two different things, getting hit in the face with a baseball and getting hit in the face with a clump of gravity. One of them will hit the tissues on your face and disrupt them. The other one will just push every bit of your substance. And so you won't feel anything.
You would feel no weight. Objects would remain stationary relative to you, or if you give them a push,
They would move in a straight line at constant velocity.
Right, so yes, it would be exactly the same if he was actually going 70 million miles an hour too, because that's just relativity. When everything has the same motion and there's no change in the speed, then everything will behave as if it's in a gravitational field and it's all equally being pushed by whatever the gravity is. But as soon as he goes near a gravitational body, then everything's going to start moving in a direction. But again, it's going to move all at the same speed based on its mass.
And you would be the very definition of an inertial observer.
So this word inertial is just useless. It's like, we come up with some catechism or Catholic, special word, Virgin Mary. I mean, it's just, it's just part of their rhetoric, some little holy word, the magical inertial.
You're not accelerating, not in a gravitational field. All the laws of physics apply in your reference frame, meaning there is no...
All of this can be explained by Galilean relativity, which is just the acknowledgement that when things have the same force applied to them previously and they have the same motion, nothing changes until another force changes it. And obviously if the other force that's changing it is gravity, then still nothing will change because gravity is going to move everything equally.
Experiment you could...
Because gravity is really just moving the electrons and protons. That's the bottom line. It doesn't move atoms. It doesn't move arms. It doesn't move heads. It moves electrons and protons. I would argue protons, but whatever.
Do to distinguish your inertial reference frame from any other.
Wooey, 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 woo.
Now here comes the big leap. Einstein looks at these two scenarios and says they are equivalent. Not just...
So they really aren't equivalent, okay? Obviously, one of them is going to create an energy event, a collision. The other one's not going to create any collision. And one of them, if it didn't create a collision, and it just kept accelerating and falling, he would gain more and more and more and more and more potential to create an incredibly big collision. So obviously, it's not the same circumstance at all.
Similar. Physically, they are exactly the same thing, which means...
So the argument is clearly physically they're not. One of them is accelerating, which means that all of its atoms are starting to change a little bit because of this motion it has inside of it. And the fact is, if I kept moving it faster and faster and faster, you could almost understand that the force would be changing the shape of the atoms, and eventually the atoms themselves would have to fall apart, because if every elemental bit was moving near the speed of light, the capacity of the electrons and protons to interact with each other would cease to work.
Man falling from roof is not in a gravitational field. There are no gravitational fields.
So says him. Of course there are gravitational fields. So his acceleration A arrow, he should have it obviously getting longer and longer and longer because he's gaining more and more, and he should have a little MV thing getting bigger and bigger and bigger, because obviously his higher velocity is meaning he has more and more momentum, that actually real momentum is being created. So the bent geodesic is creating energy, because they're not going to say it came from a force. And if it didn't come from a force, we know it didn't come because a bird hit him. We know it didn't come because somebody threw a brick and hit him. We know he's not getting his energy from some material object. So again, it's just free energy is now in the universe. That's the only... It's an unavoidable consequence of what he's saying. You can't evade the acceleration means momentum. It's a mass moving a higher velocity. That's energy.
And he is not accelerating. He is an inertial observer, just like Rocket Man.
So we know he's accelerating. So that's just a denial of an obviously fact that whether you have the Earth accelerating to him or him accelerating to the Earth, it doesn't matter. There's an MV that's getting larger as the collision becomes more and more imminent. So it's just an absolute fact that the MV is completely proportional, okay, to the amount of time these things are falling towards each other at 9.8 meters per second. That's what's actually happening per 1 second.
Whoa, whoa, whoa. I mean, okay, I can see how both of these observers feel weightless.
Oh, right, you can't really see how they do it, right? But you can say, yes, okay, I can understand that it's just an absolute fact that everything falls at exactly the same rate. So, the pen's going to fall. If I jump off the roof, and I let go of the pen, it's going to fall exactly the same speed as I am. So all my cells are moving at the same speed. So if I understand that, oh, okay, that's the catch. Nothing pushed on it, nothing banged into the pen to make it move. It's little particles are being pushed by some force. And the fact is, I know there's forces like radio waves and like X-rays that can go right through objects. Put your hand on a light table and you'll see that even regular photons can go through your flesh.
But man falling from roof is clearly in a gravitational field. I mean, he's right next to the Earth. And he's obviously accelerating. His speed is increasing by 9 points.
So we know something is obviously accelerating. Now, obviously, argument is the building is not accelerating, so and the ground isn't accelerating. So that's an extraordinary claim. If you're going to claim the Earth is accelerating, well, then go ahead and prove it with some sort of piece of evidence. But it's an extraordinary claim that every time some common event happens, I have to assume the whole universe constructed this farce. So this goes all the way back to Newton. Newton's first argument in his Principia, whatever it was to point out an argument against this relativity theory. So ironically, Newton anticipated the existence of Einstein. Clearly in his time there were people talking about relative motion. And he made this simple argument that, you know, you can spin a stick with two balls on it and these little balls will fly out into the air and spin. And the fact is that it would be ludicrous to think that somehow the universe spinning could make the balls rise. Because why would they create more gravity? Why would spinning the universe have anything to do with making the two balls rise? So it wouldn't have anything to do with it. So it really has to be the motion is in the object. Okay, the balls have the motion. The universe didn't. The universe didn't automatically acquire a zillion trillions joules of energy and start spinning. Yeah, that didn't happen. But the very fact that you have to argue this, right? The very fact that human beings are so willing to jump to the most bizarre and silliest explanation, the very fact that you have to argue that it's just plain stupid to even consider that the whole universe is moving to make a bucket have the water go up its sides. We know that the water went up the sides, or the little balls will go up in the air because of motion in these objects, not motion out there. It's motion there, and it's force there. And it's amazing that you have to make that argument. I mean, it's worse than the worst of UFO theories. And here it is, people are so willing to believe absolute nonsense.
0.8 meters per second every second, a fact that would become painfully apparent when he crashes.
There you go. That's right. It'd be painfully apparent that free energy was created. And that when the dead body is lying on the earth, it's still going to be applying 100 joules of heat energy into the earth, pressure energy. It's going to be putting 100 joules of weight, or whatever you want to call it, 150 pounds of weight into the earth. Every single second, it's going to be applying that weight, that pressure, into the earth.
Into the ground. I know that these two situations look very different, but Einstein's equivalence principle tells us the one thing to focus on.
Yeah, exactly. Don't pay any attention to all the evidence saying it's idiotic. Just pay attention to my one little thing in a separate little way of looking at it, where somehow, because you didn't pay any attention to all the other facts, it makes it sensible or possible. So just ignore the reality, and then you can believe that trees feel pain. Ignore that brains are the only thing that feels pain, and just pretend trees feel pain because, you know, they feel like it. They think they do with their non-existent brain.
The experience of the observer. If they feel weightless, then they are in an inertial frame of reference.
So again, it's just silly to talk about what you feel. So that's another giveaway, isn't it? As soon as somebody talks about what they feel, isn't that doing the wooey thing, little girly physics? It's that kind of baby talk. It's not about what you feel, all right? It's about what you can understand, and we can understand what's happening. That, yes, quite obviously, whatever this mechanism is, it's pushing every little bit of him the same. His kneecap is getting pushed just as much as his eyeball, just as much as his hand, just as much of his shoe. So they're all getting pushed evenly. So he can't detect that he's being pushed because he can't feel it. You can't, just imagine if every surface on your body was pushed at exactly the same time, it would be really hard to feel your motion.
Every bit as good as Rocket Man's out drifting through deep space. Imagine if Rocket Man coasting along at...
It's all imagine, and imagine stuff that isn't true, and you know it isn't true. So just do that. Just imagine that you can break all the rules and forget about all the real facts and just draw the picture the way you want it to be.
Constant velocity and not paying attention comes upon a planet a long way off in the distance. An external observer might notice that the path of the rocket bends ever so slightly.
Right. So again, if you had to bend your path, you'd only be able to do it by moving the whole rocket, right? The fuel's in the rocket, the tank's in the rocket, only the rocket will be moved. So obviously you're not going to move until you hit the surface of the rocket and share its motion. So you have to have contact with something to be able to get pushed. You have to physically contact matter. Matter has to push on you. The floor has to hit you. The walls have to hit you. Something has to hit you and give you motion. So yes, you're going to feel all of that. But we've already stated, yes, gravity does this thing that most other things don't do, which is it applies the force equally throughout your entire density. It doesn't allow you the opportunity. Well, it does so at least beyond your perception. You can't tell whether your feet are moving a little faster or sooner than your head. It's not enough of a difference. So yes, gravity is obviously a very discrete force, very very subtle in how it influences your molecular structure. But that's all it is. It's not magic. It's still a force. It's still giving you momentum. And a force had to come from someplace. And obviously, I'd argue it comes from the radiant energy actually created by gravity.
Towards the planet. But inside, Rocket Man would remain oblivious.
All right, I guess I'll take a little pause here just because the chat looks awful noisy. Let's see, one jackass just rambling. Yeah, I'm not going to read anything you posted, moron. So just fuck off with that shit. He's so important. Yeah, so important. Oh, God, humans. Pitiful.
He feels no force, experiences no acceleration.
Right, so this is all part of the... Yes, you could have just said that at the beginning of the video. Gravity has this feature that it moves you in such a way where you can't feel it pushing you because it pushes every little bit of you at the same exact time.
As the rocket gets closer to the planet, it goes faster and faster. But Rocket Man's...
Right, so we know that the entire thing is, the entire collision, the entire vector bending, that is, you were going this way. Your rocket's now going to have a component of velocity this way. That entire component is free energy. It's free energy. It's free energy. Yeah. Because you don't account for where it came from.
still feels weightless. For him, nothing has changed. So where on this journey would you say the frame of reference changes from inertial to non-inertial?
All right, so again, more whatever religious talk about the, you know, the virgin birth of inertia.
An onboard accelerometer would never even register a blip.
Yeah, we know, because accelerometers have the same problem we have. It has to compare two different things, and the two different things are going to be moving the same exact way from the force of gravity. So obviously the accelerometer can't tell, because it's like it's got two things this far apart, and it's saying they're both being moved exactly the same. Well, it can't see that acceleration then. It can only see if one part of the box is moving and the interior part isn't moving. So obviously it's like you feeling your stomach moving or something. Yeah, it can't detect the acceleration if it's even.
he has continued on his inertial path through space-time. So the logical conclusion is his frame of reference is inertial up until the instant he crashes into the planet.
Right, whatever this means, it's inertial. He's obviously moving, gaining momentum. There's going to be a collision, and yet he's talking about some kind of unchanging condition. There's not an unchanging condition. 9.8 meters per second is happening. Well, obviously at that distance it's less than that. But that's what's happening. He's gaining. Every second he's gaining a portion of gravitational fuel. So, and then he describes it with a crash. So, and that's it. That's the last indication that he's going to account for the fact that he just created an energetic event. That more than just the initial velocity the spaceship had, it gained extra velocity from the gravity and collided. And it created energy. Energy is now dispersing throughout the universe from that event. And where did the energy come from? Where was the energy the day before it became part of the bent geodesic and pushed the spaceship into the Earth? Where was the energy the day before? Clearly these people don't think Descartes was right. They don't think energy is conserved.
Looks like trouble in
Unfortunate.
Paradise as the hottest festival of the year.
Silly people and silly commercials. I don't know how these commercials sell anything. They make me hate the company that puts the commercial on. You know, it's just like, oh, fuck these assholes. Oh, skip. There's the button. Sorry, didn't see it. All right, now we miss a little bit of the speech because of this stupid commercial, but we'll be able to figure it out.
In the curved path of his rocket without gravitational forces or gravitational fields.
Right, exactly. How do you do all of this mechanical changing of the universe and then pretend I don't have any energy to explain, and I don't have any? The fact is, it's going to be the energy is going to be dispersed.
Answer is curved space-time.
It's not an answer.
Focus on Rocketman's observation that the whole time he felt like he was
Moving with constant velocity in a straight line.
So more baby talk about what he feels. Gooey, woo-woo. You know, this isn't physics, this isn't science. We already know you can't feel gravity. That's how it works. It moves everything exactly the same. I'll say it again. It moves everything exactly the same speed. You can't feel something that pushes every bit of you the same speed because you only feel something when one part of you moves and another part of you doesn't. You can't feel any other way. There must be something uneven in the motion of your parts for you to have a feeling.
He was moving in a straight line through space-time. But space-time around massive objects like planets is curved. So that's why his path appeared curved to a distant observer.
All right, so it just appeared curved. It wasn't really curved or some kind of nonsense like that when clearly it is curved. Okay, it's a curved path in an orbit. It's no doubt about it. It's not a straight line. It's just, this is a ridiculous argument that somehow it's a straight line it's traveling when clearly it's not a straight line. I mean, it's just ridiculous to say it's an illusion that it looks curved. It's not an illusion. The change is real. It's a leasing. It's changing its direction constantly. It's a real direction change. It is not a straight line. They're actually saying that. They're saying around a circular orbit or even a parabola is a straight line. It's clearly not a straight line. And somehow you're broken because you're seeing the parabola. No, I'm not broken. I'm seeing what is the actual thing, just as the surface of Jupiter or the sun even. It's round. It's not a straight line.
Now this isn't as unusual as it seems. Airplanes, for example, always try to fly the shortest route between cities. Essentially, they just go in a straight line. But
yeah, well, they're going up first, so that's all part of the deception. But obviously, there's advantage to taking advantage that the Earth is smaller at the top and at the bottom than it is in the middle. So flying the shorter path is just kind of a, yeah, obviously that makes sense. Go across the atmosphere that's on the part of the Earth that's a smaller circumference. Travel the smallest circumference.
since the Earth's surface is curved, the shortest path doesn't look like a straight line. These shortest
Right, so the shortest path is to go, to allow yourself to go north, or if you're at the southern latitude, south.
paths over curved
As the Earth is smaller there.
surfaces are called geodesics, and we use that same word, geodesics, for the straight line paths followed by inertial observers through curved spacetime.
So again, that's nothing, again, he won't draw us that picture because it's a ludicrous picture. There's no curved paths, there's no space-time. Time is not a dimension, there's only 3 physical dimensions. Dimensions have a rule, okay, right angles. There's all right angles. Dimensions intersect with all right angles. There's no more room for anything to intersect with all right angles, so nothing else can intersect, so there's no other dimensions. So they're just breaking vocabulary all over the place. There's no point in having vocabulary because they just break the rules.
Here's another analogy. Imagine you and a friend are standing 1,000 kilometers apart on the equator. Now you both...
So again, this is only because the Earth gets smaller. The circumference gets smaller. So obviously you have to be driven together because the circumference is getting smaller. You're starting on a circumference of whatever, 40,000 miles. And if you keep going all the way to the North Pole, you'll be on a circumference of 14 inches. So obviously you're going to be closer together. Obviously. Duh.
set off due north. Over time, you will come closer together, ultimately bumping into each other at the North Pole. It's as though there was a force pushing you together. But you didn't feel a force, and your friend didn't feel a force. Gravity...
Right, there wasn't any, and it's just because, yes, the fact is you were just walking straight lines that converged. They never were parallel lines. You just pretended they were parallel lines. They're not parallel lines. They're a triangle. They were inevitably going to converge.
is just like that force. It doesn't actually exist.
Okay, so again, it's just silly. So obviously there's no force driving the two people together. It's nothing like that. It's just the fact that you have two lines and you're pretending they're parallel, and they weren't. They were always converging, and they converged. So what? That doesn't mean anything. Just too silly.
The real reason for you coming together was that you were both on straight paths, geodesics, on a curved surface.
So again, he said straight paths, but he's not saying straight paths that inevitably converge. They're not parallel lines. They're straight lines, but they're not parallel.
Astronauts on the space station are weightless. That means they too are inertial observers traveling on...
So again, weightless is a silly word, okay? And so what you understand them to be is they're in an environment where they have, through their velocity down, they have basically are free falling. So there's no force pushing against their motion in the downward direction, because they're constantly falling down essentially, and they keep missing the Earth. But they don't gain any velocity. So they fall, but clearly the gravitational force, their velocity takes it away again. So they just keep converting into a higher velocity, a lower velocity, a higher velocity, a lower velocity, keep getting rid of the gravitational energy. So they're not going 9.8 and then 19 and then 28, and they're not gaining velocity. They keep falling at exactly the same speed.
A geodesic, but the Earth curves space-time around it,
Baby talk.
which is why their straight-line path appears as a helix. It only looks like a circular orbit if you forget the time dimension.
So obviously it doesn't only look like, it is exactly what it looks like, a circular orbit. I mean, you could argue that the whole thing could be moving through space this way, and the whole galaxy could be moving through space that way, and so you can turn it in any kind of monstrous shape you want. But the absolute truth is, from our perspective and our understanding of the fact that the rest of the universe isn't fooling us by spinning the entire universe, the fact is, spinning motion, as Newton demonstrated, spinning motion proves relativity to be a very weak theory. Because spinning essentially can only be explained as a local phenomenon. It has to be local energy.
Don't forget, we are all moving through space and time. Space-time.
No, we're not. It's just a fable, and a really silly fable. Talking fish silly.
This is the standard bent sheet analogy for curved spacetime. But I think this demo is misleading.
Well, yeah, the biggest misleading part is that there's, look at all this bouncy friction you just created in it. And so what doesn't happen is you throw a marble in, and that marble doesn't just fly out the other side, which it should do. There should be only two possible outcomes for a single ball thrown in there. It either hits the yellow one or it flies out the other end. There's no such thing as orbits unless there's some mechanism that slows that blue ball down. So if it doesn't hit anything to slow it down, it should just fly right back off. So it's really a poor demonstration of actual gravity.
It allows you to fool yourself into thinking you understand general relativity when the intuition you're actually drawing on is just that objects like to fall towards the middle of a well.
Well, I mean, it's not even... Obviously, you're using gravity to demonstrate gravity, or to model gravity. So you're sort of cheating. Your model of gravity is cheating by using gravity to make the model work.
Due to the gravitational force. But in general relativity, there is no gravitational force.
Yeah, right. There's just some kind of screw force or something, some sort of spiraling line that somehow carries things into the center by some magical mechanism. Bullshit.
What you should be thinking about is objects traveling on a straight line path through spacetime. It just so happens that spacetime is curved around massive objects. So that straight line path doesn't look like a straight line.
So again, there's just no point in saying it's a straight line because it isn't. But okay, fine, whatever. There's no point in arguing with this silly nonsense. It's the line is as long as it is, and it is as curved as it is, and that's what it actually is. And you pretending it's some other dimensional object happening in some other dimensional space is just talk.
Matter tells spacetime how to curve, and spacetime tells matter how to move.
Now, force tells matter how to move, and matter moving changes the force. So, matter moving tells the force where to go. The force hitting matter tells matter where to go. Unfortunate. Gotta hit the skip button again. Ugh. Force me to do work. Alright, put the sound back on. Alright, let's see if we have any comments that are relevant and interesting. It's a very low probability, but we'll see. See what happens. Alright, let's see. Go back to the beginning. Spooky action opens up to all kinds of wacky theories. Again, spooky action is quantum mechanics by Einstein's word, so I'm just saying that Einstein was obviously, I think the point is Einstein was a bit of a hypocrite, because this theory of his relativity is incredibly spooky. Okay, why do you have to be so rude? Oh, you're just useless. Poor fella just wants attention and doesn't know how else to express. Okay, so I don't understand. You're just going to defend inane propaganda nonsense for the rest of your life. Is that all you're going to do with your life? I mean, it's junk physics. And nobody should be upset. Nobody should be irritated. In the end of this video, he's going to completely misdescribe the Eddington experiment when clearly it's easy research to do. Easy. So it's going to be more just jargon and propaganda. And that's all you fuckers live for, right? I should have never looked at these comments. I mean, these people are just such sacks of shit. Ugh, it's disgusting. Understanding, what does that mean? Does the difference in heat inside planet dictate gravity's strength, or does mass of planet dictate it, or both? Well, that's a stupid question. Obviously the mass is the only thing gravity is interested in, so the higher the mass, the more electrons and protons are moving. Obviously that means more fucking heat, retard. The bigger the object, the more pressure. Can't you understand its pressure, which is weight? So a little tiny asteroid, well, it's not very much weight on the center, so the center's not going to be very hot, is it? I have to do all the thinking for you, do I? I'm not buying time as a dimension. Well, at least you figured something out. Lobster. What kind of name is that? Okay, I searched for Veritasium and got to this live. If this host is right, where do I go to learn physics as a layman? Yeah, well, why are you searching for Veritasium? You must know what physics is, so you seem like a liar. A complete liar, right? Yeah, you deserve a timeout, too, just for fun. Totally, I mean, these people can't be on the subject to save their stinking, lousy, cruddy, garbage lives. Alright, so that was a waste of time, as it usually turns out to be. Alright, so we shall continue and such.
What happens if you turn on the rocket thrusters and accelerate at
Right, and you accelerate just the rocket. You're not accelerating you're not accelerating anything in the inside the rocket, just the rocket is getting accelerated. So clearly not like gravity at all.
9.8 meters per second squared. Well, someone outside would see all objects remain stationary, while the floor of the rocket accelerates into them.
I mean, it impacts them, and then their body has to absorb the acceleration and the velocity. And as long as you keep accelerating, then the body will keep feeling the floor. But as soon as you stop accelerating, then it's not going to feel the floor anymore.
Inside the rocket, everything would appear to accelerate down to the ground, and you would feel a force pushing up on your feet. The same force that's pushing up on you
and anybody with a little bit of logic can understand, yes, I can do that in any direction. It wouldn't matter. And all I've done is I've moved the container you're in. So you're in a steel box. I could move the container this way and make you hit the wall. I could move the container this way and make you hit the floor. I could make you hit any surface. Yeah. Not really challenging as an idea.
As you watch this video.
This situation feels exactly the same as being at rest on the surface of Earth. Because we are at rest on the surface of Earth.
So obviously you're not at rest. So, like I said, it's 150 pounds. pushed into the earth. Okay, that's like 100 joules of energy, 150, I think, being smashed into the earth right now. 90, whatever, 75 joules, smashed right into the earth every second. Yeah. So yeah, this is a nothing event, being on Earth, and you can feel it. Stand up all day, your feet hurt. Sit all day, your ass hurts. Not complicated.
Now I want to ask you, are you watching this video in an inertial frame of reference? Well,
obviously not. Yes, exactly. Obviously, I'm not accelerating, because obviously I keep hitting the fucking ground. And that's the only way I could feel the ground is I have to hit it first. I hit the ground pushes me back. Gravity is pushing me, so I don't feel myself pushing into the ground. I feel the earth pushing back. Because it's matter pushing back. A force pushes me in, matter pushes me back.
I mean, do you feel weightless? No. So you are not an inertial observer. Your situation is exactly the same as someone accelerating.
So again, I could change the circumstance, or I could be on a trampoline, or I could be on some other kind of mechanism that absorbs a lot of the instantaneousness of my hitting a hard surface. And so it would dampen the effect, and then you could just have kind of a bouncy and whoopsie, and turn all the gravitational energy into a big swirly amount of energy, right? So it won't be anything like the hard surface.
Operating on a rocket ship in deep space. And let me be clear, I don't mean that being at rest in a gravitational field is like accelerating in a rocket. I mean it is the exact same thing.
It's not. So again, he's teaching this as if, again, this is just polluting young minds with this nonsense, all this silly confidence, and he didn't deal with the creation of energy at all. He's not going to deal with the fact that your bent geodesic creates collisions, and it in fact also makes sure the collisions have a ton of energy in them, and all of that energy somehow disappears. It's not in the universe.
You are accelerating, and there is no gravitational field. Gravitational fields do not exist.
Oh, just hideous, insidious nonsense. Garbage physics. Garbage science. Defended by morons.
Now, I know that sounds crazy, but come with me for a minute.
So, this won't prove anything. So, again, there's no evidence of this garbage theory. Waste of time.
This is you. In standard Newtonian physics, we draw your weight force, the force of gravity.
So I don't know why exactly it's drawn there, right? So you can understand that we know it's a force, and we know it's either pulling, which is ridiculous, so you draw the arrow pointing down and below the object, or it's pushing. And clearly it's, the inverse square law. It's the opposite of a light bulb. It's that simple. The light bulb's doing the inverse square law. All you have to do is imagine the photons going the opposite direction, and imagine that they're more mundane, more discrete. And that's gravity.
Pushing you down, and the normal force from the floor pushing you up.
So there's no, this idea of a normal force is again bullshit. It's in equilibrium. So obviously when you increase its pressure, that increase in pressure has to go somewhere. So it either expands the earth, or it pushes on something that isn't as expanded as it should be. So when you push in, either that push in energy, like in a balloon, you could have different pushes, and you could push in and it pops something else out, or the energy just comes back and pushes you out. But there's the fact is the pressure is at equilibrium, so the pressure will remain the same. unless you're adding material from outer space, then the mass is increasing and the pressure will increase.
We say these forces are equal and opposite, so there's no net force on you.
So again, there's no such thing as canceling. So you can't cancel a force. So again, we'll go back to the steel balls hitting each other, and I don't let them bounce. They have to convert the energy. All of the momentum has to be converted into heat. So you can't just cancel anything. There's no canceling energy. The energy going down has to continue going down. There's just no other way to get around it. It has to. And it's doing it in the form of heat.
You are not accelerating. But in general relativity, gravity is not a force. You have no weight, so the only force on you...
So again, it's just kind of silly. No force creates momentum. And whether you think the Earth has the momentum or the person falling has the momentum, it doesn't matter. The fact is, the theory creates momentum. And you have to account for the creation of the momentum, because it has to go somewhere. And it's going to go somewhere by their own entropy argument as discrete little bits of dispersed heat. It's heating the universe, undeniable.
Are these normal forces pushing you up? So you are accelerating upwards, but I'm not moving up. Relative to what? I mean,
relative to the moon, relative to Saturn, relative to Jupiter, relative to the Alpha Centauri, relative to every single frickin' thing in the universe.
Relative to the flip chart and the floor and basically everything in the...
Yeah, there's no point in talking about everything in the room, okay? Because yes, it's all doing the same thing. It's a mass pushing into the Earth, and the Earth is pushing it back up. It's all doing exactly the same thing. So you don't compare to everything doing the same thing. You look out your window and find a bird flying, or you find something else going on, and you say, okay, there's no way the bird can do this, so yeah, I can make a comparison to the bird. A cloud.
This room, but all of those things are in your frame of reference, which you know is not inertial.
Relative to everything in my rocket ship, I'm not accelerating.
Again, so just more nonsense. Yes, of course not, because you're attached to the floor, so now the rocket is now directly connected to your mass, and so it's pushing your mass, and you feel it pushing you from the floor. No doubt about it. You have to be able to feel the weight. Doesn't matter whether you think the weight is the rocket pushing on your feet or your feet pushing on the rocket. It just doesn't make any difference.
What you need, if you really want to measure your acceleration, is someone in an inertial frame of reference, like the guy who fell off the roof.
Oh, it's too silly. So the guy you know has gaining acceleration and momentum every second, you go ask him about whether you're not moving. I mean, just too ridiculous. I mean, that's just so silly. Go ask something that's moving whether you're not moving. I mean, just nonsense. These commercials are irritating.
Up at 9.8 meters per second squared. I think what this shows is that what an acceleration really is it's a deviation from a geodesic. You can't follow.
Okay, yeah, somehow the volume got messed up here. Sorry about that. This whole video, the volume's not what I thought it was. Yeah, so that's a little irritating. But, you know, as tragedies go, it's probably not the worst tragedy. Because, you know, he's talking shit.
A straight line path through space-time because the floor prevents you from doing that. It applies a force upwards on you, so you're accelerating up.
Right, but the net force is not up because you, in fact, had to hit the Earth first for it to be able to apply pressure to you. It can't apply the pressure until you hit it and push into it, it's not going to go chase you and apply the pressure. It only applies the pressure as you push into it and acquire the pressure. It takes time for 10 pounds to weigh 10 pounds. I could put 10 pounds on a scale. It takes time for the 10 pounds to get into the earth, because initially it's stored in the spring. And the same thing happens when you're pushing into the earth. There's a delay between when you push in and when the earth reaches the appropriate back pressure to push you back up. It can't push you up instantly. It's not an elastic. It's not a hard elastic collision.
But if I'm accelerating up, and so is everyone else around the world, and presumably the whole surface of the Earth, then shouldn't the Earth be expanding?
So obviously that would be the obvious answer, that obviously you can't move unless you moved. Yeah, that's right. You can't be accelerating unless you've changed your position in space. Period.
No. It is possible for you to be accelerating even though your spatial coordinates are not changing.
So that's just nonsense. So I mean, it doesn't make any sense. So this is like, physics says lots of things like holding this is doing no work, when it's doing work. And they say when you throw a tennis ball at a wall, twice the momentum went into the wall. Yeah, even though the wall is not moving, it has twice the momentum. So even though the V in the MV is 0, it has twice the momentum. Even though the V is 0, it has twice the momentum. Now those are the silly things physicists say.
I will show you one equation from general relativity.
Okay, well this I can smoke.
This says that the second derivative of your position with respect to time is
ridiculous
equal
crap.
to your acceleration. That's just F on m. And if you were in flat space-time, well, this is exactly what you're saying. If you're accelerating, your spatial coordinates have to change. But you're not in flat space-time. And this term is related to the curvature of space-time, and this is your velocity through time squared. You don't have to worry about the details here. The point is, your position can be not changing. This can be 0, which means your acceleration must be exactly equal to this curvature term times your velocity through time squared. So in curved space-time, you need to accelerate just to stand still.
A lot of this may seem more complicated than Newtonian physics.
No, it's not more. It's silly. That was just a bunch of silly shit, right? I mean, that wasn't anything. There was no grounding for this equation and any of these things equaling each other and anything like a time squared, whatever a time squared would be, a cube of time. I mean, it's geometric nonsense to start talking about time in cubic volumes. Ridiculous is what it is.
But one classical mystery looks a whole lot simpler in general relativity, which is why all objects fall at the same rate.
Right, and so if you just understand that, you're supposed to understand that the electrons and protons are in the same empty space that the moon is in and the earth is in, and that the electrons and protons in that vast empty space are the things that actually get hit by forces. So photons and other things, other radiation hits electrons and protons. It doesn't hit atoms, right? There's no surface of the atom and it hits the surface of the atom, or it hits the surface of the compound, or it hits the surface of the human being. No, it hits electrons and protons, and they are quantized, consistent objects. All electrons are the same, all protons are the same, so they can only collect the force in chunks, in discrete bits based on their existence. They are the sail. So the sail material is made out of the number of electrons and protons. No other thing describes how much capacity to catch the gravity wind. And so obviously everything falls at the same rate because the only thing collecting the force are electrons and protons, and all of them move exactly the same in the same force. So if the electrons and protons are in the same force, they have to all move the same speed because they're all the same. I mean, it's so obvious an answer.
Now, I have made a number of videos on this topic, and I would always give the standard Newtonian explanation. The only force on a free-falling body is its weight, g(mm) on r squared, which equals its mass times acceleration. You can cancel the object's mass on both sides of the equation, hence all objects...
Yeah, so they cancel one of the masses, which is the same argument I've been making, but anyway, that the formula was crap anyway. And the only part that matters is each object creates its own gravitational field, and all you can do is add those two fields. There's no point in trying to multiply them. So that was a huge flaw anyway. But anyway, you're going to move based on what the other object has done to the field, and it's going to move based on what you've done to the field. And what you've done to it essentially is absorb it as heat. So you've absorbed gravity, created heat inside of you, and the differential is now the difference in the time between when that heat will leave and when the new force hits me. So the new force is hitting me constantly. The heat's going to leave much later, so I'm in a differential, and that's what you fall in. So everything's falling in a heat differential. The universe is hot. It's pushing heat at you. And the fact is the heat takes time to get through the earth while it's heating it. And so you're stuck waiting for the force that was supposed to push you up. And it's not there. And so you have more push up here than push from below. Simple answer. That's what gravity actually is. All of this nonsense he's teaching is just a fable, way under evidenced, and way under reasonable. It's wooey and weird, and the simple answer is yes, gravity's a force. The universe has it, heat, in the form of radiation. The radiation streams into every object from all directions, and the fact is it takes it longer to get through thick matter than it takes it to move through regular space. And the fact that it takes longer to get through the thick matter means you're always in a differential. And the differential gets stronger and stronger based on how much matter the force has to go through. Simple answer, better answer.
Objects will have this same acceleration. The mystery is why we could cancel these two m's.
Alright, so again, the why is because you're asking what's really the force you're going to be moved by. You're not asking what's the force the other object is being moved by. It's sort of irrelevant in most cases. Obviously those two m's are going to be a huge, gigantic difference in most cases. But you're still just asking what's my portion of the problem. So if you use two m's but you had two moons, so of equal mass, you're just asking how much am I being moved, or you're asking how much are they being moved. You're not asking what's the collective distance you've moved. You're asking what is my momentum going to be. That's what the MA means, is momentum. That's a replacement for MV. MA is a replacement for MV. You're just asking what's the change in my momentum. The change in your momentum is what the other object is creating as a field. You're getting affected by the other object, and so you're going to move and it's going to move. You're not asking the question, how fast is the other object moving towards me? It's going to be the same answer in the moon case, but I'm just saying you're not asking that question. You're asking what's my momentum, not what his momentum is.
The one on the left was gravitational mass, the property of an object that creates and experiences a gravitational field, while the m on the right is inertial mass, a measure of resistance to acceleration. Why should these two conceptually different properties be numerically identical? Scientists...
So there's nothing identical, there's nothing mysterious. Your mass will decide your momentum. The velocity will be decided based on your mass. The heavier you are, the more force you're going to collect in gravity, the more momentum. The fact is, the heavy thing hits the ground harder than the light thing. Fact. Because it collected more wind. It collected more energy.
Have spent a lot of time and effort experimentally testing down to around 1 part in 10 trillion that these two types of mass really are the same.
So just a vague reference to them, one of their magical experiments that magically did something magically. You know, I don't think it did anything magically.
But in general relativity, there is no mystery. All
Mikey Sherrill supports the failed energy plan that tripled our electric bills this summer.
Oh, brother. That's not even, my electric bill did not triple, but whatever. Maybe 40%. Oh, I just love these commercials. Guy spraying his balls. Can't get higher class than that, can you? No way, right? That's as classy as it gets. I wonder if they show the commercials when they play the video in some schoolroom somewhere. It's just so tacky. God damn. What this planet is turned into.
appear to fall the same way because, well, they're not.
What is he doing? He's wringing a towel? What the why are they wasting their time wringing towels? I'm strangling a towel. It's an orange towel. Because it's fun to strangle things in no gravity.
Not accelerating. They're just following straight line paths through space-time until they encounter something that stops them. Like the objects in the rocket ship, they appear to accelerate at the same.
So all this appearance crap, really, it's not about appearances. We're supposed to be smart people. We can see past what the overt images might look like, and we could understand, oh, that's the trick they're doing. They have the camera moving with it. Oh, they don't have the camera mounted. Oh, okay, it's a trick. We can figure that out.
Same rate because they're not really accelerating. It's the floor accelerating into them.
It's object moving and obviously creating again a collision. All right, and the collision means that you are going to share your condition, and obviously it's big and heavy and you're small and light, so you're going to do what it tells you to.
Now, a lot of this might seem pretty far-fetched, as it did back in 1915 when Einstein proposed it. So he he proposed it. So again, this is part of the, just the lore. So Einstein didn't do a damn thing on his own volition, all right? And he was basically forced, okay, to explain things. So he didn't provide the mathematics for Mercury's precession. He was provoked. Eddington said, well, if you're really going to sell this theory, we need something. So why don't you explain why Mercury screwed up? And so then Einstein spent 6 months with a couple of German mathematicians contriving Einstein's field equations. So that's what the real truth is. Okay, it didn't pop out of nowhere. It didn't pop out of Einstein's own imagination. It popped out of the fact that, okay, we need something to make this some little wedge we can use to say, look, you have to believe in this theory because it does this thing that nobody else could do. And obviously it does it with the most convoluted mathematics in the history of mankind. So that's sort of a giveaway that, oh, is that really the answer? Convoluted mathematics that nobody really can even do? I've never seen anybody go all the way through it and show exactly how it predicts Mercury, because it would probably take hours and hours and hours. Very cleverly came up with a measurable prediction that scientists could make to test his theory. Imagine that this rocket ship is coasting through deep space. If you shine a light beam across the rocket ship, well, it'll do exactly what you expect. Light travels in a straight line and hits a point on the opposite wall at exactly the same height as...
Okay, so now if you understand that these are photons, okay, any kind, even if you think of the photon as being this little wavy, snaky thing,
It has a length, it has a thickness, like in a laser beam. And so what you could understand is that it, you know, it's going straight across, and all you're doing is moving the side of the ship. The ship's moving. So the light beam's going straight. So now we have the circumstance where we're talking about straight versus curved lines and what you're going to see. So he says that somehow the observer is going to see, no, he's not going to see any such thing. He's going to see a straight line. The light never goes, never bends, never goes crooked. All you did was move the damn target. So the photons aren't bending in any way whatsoever. So it's just such a lie. So you can hear it for yourself, you know.
As the source. But now, what if this rocket is accelerating? Well, to an external observer, they're still going to...
Again, it has to be accelerating, let's understand it, at a preposterously high speed. Okay. And it doesn't have to be accelerating, it just has to be moving at a velocity. It just has to have a really, really fast velocity.
Going to see the same thing, light traveling in a straight line. But inside the rocket, during the time it takes...
So again, he said accelerating, and it doesn't have anything to do with acceleration. It has to do with velocity. So theoretically, the side of the ship is moving past the photons, even when it's going very slowly. It's just that it's unmeasurable. It's such a tiny amount. So compared to the speed of light across a few meters of a spaceship, even if we make it 10 meters, there's no time for us to see the ship move the side. So it has to be a pretty fast speed that the ship is moving. So you got to go half the speed of light before you are going to notice that the light hit the wrong place. But an observer on the outside is going to see a dead straight laser beam. They're not going to see anything bending, because it doesn't bend.
Takes for the light to travel across the cabin, the rocket will have sped up. So by the time it hits the other wall, it'll hit a little lower than before.
Right, but it won't do that. If it's doing anything to the interior observer, if the interior observer could actually see, you know, in tiny frames, it would see the fact that the light continues to go straight and it just steps. Okay? It's always going straight. It doesn't travel a longer path. It's exactly the same path, length. It never gets any longer. So that's the lie. That's what they're trying to tell you, that time is warped, because that line is going to be longer, which means the speed of light had to go faster than the speed of light, because it's a bent line. Well, it was never bent. Just as your circular orbit isn't really a circle. It's a bunch of little tiny straight lines.
So in an accelerating frame of reference, light deflects down.
So it doesn't, and it's not accelerating. So he's not even, like I said, it's really important to be precise, because you're doing this thing seriously, millions of views, all of that crap. And it clearly has nothing to do with acceleration. It just has to do with velocity.
Here, I am dramatically exaggerating the effect. Even if I were accelerating up at 10 Gs, which would probably kill me, the deflection would be on the order of the width of a proton. Still...
Right, because that's the huge difference between our human speeds and the speed of light. Gigantic, humongous difference, an almost incomprehensible difference.
It shows that an accelerating frame of reference will bend light.
So we know it didn't bend it, okay? You can know it, I know it for sure. You can know it if you're reasonable and fair, that it really didn't bend the light. All you did was move the target. Just take the whole ship away and just have the two sides of the ship, and all you did was you shot some light from this side, and then the target side has a little target written on it. You moved it. You moved the target. The light went straight. Didn't bend. So again, that's where he's so unfair to the facts. All you did was move the target. It's like if it was a window that you were shooting the light out, you could understand, okay, here's the window. I'm moving the ship at, half the speed of light. The window, I shot the light, but the window just moved. There's no window anymore. Duh. I didn't miss the window. You moved the window.
So, Einstein reasoned, light must also bend when it passes a large mass.
Right, so this is where they propose something extraordinary and they have less than ordinary evidence. So this is my opinion, it's less than ordinary. It's all flawed and defective, okay? And so now he's going to make up a fake story about the Eddington experiment, and it's really easy to research, and he didn't bother.
But where do you find a mass large enough? Well, the only obvious huge mass near the Earth is the Sun.
All right, so a fact is that Einstein actually considered Jupiter because it has the huge advantage of not spewing tons and tons of plasma. So it doesn't have a corona and it's not shooting plasma. Some of this plasma from the sun hits the Earth. I mean, that's the aurora borealis thing. So, there's a ton of crap flying off of the sun. So the very idea that it's the cleanest place to go looking, it's not the cleanest gravity. It's a very foggy atmosphere around the sun. You could say the atmosphere of the sun reaches all the way out to the Earth, technically. It's not a thin atmosphere you're looking through. It's not thin enough. Where Jupiter is creating a little infrared radiation, but it's not radiating any plasmas. It's not shooting a bunch of particles off its surface. And so you have to also understand that the gravity on the surface of the sun is only 80 times what it is on Earth. Yeah, I think that's the right way to say it. It's not that huge. It's not like a million. It's not what you think. Okay, in terms of, it should be incredible. No, it's not. All right, and so you can understand that if you're close to the surface of Jupiter, it might be the same as where you have to look when you're doing it with the sun. Because to do it with the sun, you have to look way out here because it's too dirty in here.
So the ideal experiment would be to look at light passing just next to the sun and see if it is deflected.
Right, and that we have been able to do for 60 years from space. So from space, there's 400 times better seeing. So the experiment is 400 times easier to see. 400 times. And they haven't even attempted it from space. That's what you're supposed to believe. A 5-minute experiment, you don't need an eclipse from space, and they haven't even attempted it ever. Not with a telescope inside the space station, not with any of their big telescopes, not with any camera on a satellite. They have all these satellites, can almost read license plates on your car. And so let's argue that why don't they just point one of those satellites just outside the sun there, half a radius or a radius away, and do the experiment. 5 minutes. Never even attempted. That's good science? No, that's propaganda, distortion, that's shenanigan science. It's clearly they've tried it and it didn't work. That's probably the right answer. They're only going to publish if they succeed. They're not going to publish if they fail.
They light from distant stars. The problem was, of course, the sun is just so bright you can't see stars right next to it. Unless there is a total solar eclipse.
Right, you can't see stars next to it because of the Earth. Okay, the Earth was the biggest problem, the atmosphere. But regardless, yes. And so, but as you can see from the picture of the eclipse, you can see that there's all this crap flying around past those edges. So that's just giving you an indication there's a huge amount of radiation. So you can't look where the surface of the sun is. You have to go maybe a radius away where the gravity is already 4 times less twice the distance, 4 times less gravity. So you can sort of see the problem. The further away from the sun you go, the clearer the vision, but the weaker the gravity.
Which is exactly what happened in 1919. So Arthur Eddington set out to take pictures of the stars right next to the sun during...
So it wasn't right next to the sun. So again, this is an important detail, especially looking at the image. Look at the image. Right next to the sun's not going to work. You have to go far enough away where all of that brightness isn't going to screw your vision up. So again, it's a lie to say it's right next to the sun, because it's going to be almost a full radius away from the sun to be credible. And that's the truth. And now we're 4 times less gravity. So again, it's just such a... They can't tell the truth to save their lives. Now, they're not going to tell you the story either that 2 years before Eddington did this experiment, there was another eclipse, and they were supposed to do the experiment then. And the fact is, the war got in the way, World War I, and so they couldn't get the experiment done. And the fact is, though, Einstein changed his theory in those 2 years. So if they would have done the experiment in 1917, Einstein predicted that gravity only bends the light 1 amount, not twice as much. So his prediction would have been completely different, and their finding would have been completely inconsistent with his theory, blah, 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 blah. So the whole thing is really dirty. This isn't a pristine story of accomplishment by mankind. This has all kinds of dirt and shenanigans in it. Then there's the whole idea that some of the glass slides just magically disappeared. They weren't preserved. There's almost no credible historical record. So, I mean, the whole thing is just really, really dirty science. Now, I could even mention, as Veritasium isn't going to mention, that Eddington admitted in his own journal, he's taking a journal while this whole thing was happening, and he pointed out how, the weather is dismal, everything went wrong. I was expecting 10,000 stars per glass slide. He got 1,000. So that's a 10% of the data quality. So this is a highly difficult experiment to do, and he got 10% of the data. He states in the journal, I would not stake my life on these results. And yet Veritasium is telling us that this is a pristine experiment that proved Einstein right. That's not good science. That's gluing the head of the wrong dinosaur on the skeleton. Okay, it's just bullshit science. Let's just make up the story and contrive a fable to defend it. It's junk science.
Totality. And what he found by analyzing those pictures was that their positions appeared deflected by the precise amount predicted by Einstein's general theory of relativity.
And again, the joke is if the first eclipse took place, the prediction would have been proven wrong.
The result was twice the deflection some had calculated.
So just imagine this. This is not, by their description, this is not an extraordinary claim. So gravity, which moves matter 1 unit of distance, somehow it moves the smallest, discretest thing in the universe, a photon, twice as much. The fastest, smallest thing in the universe is just magically bent. Magnetism isn't bent. As far as we know, electricity, nothing else is bent, just photons. Does that make any sense to you? It makes no sense to me.
Using a strictly Newtonian model. And general relativity has passed virtually every test put to it over the past 100 years or so.
So that's just overt propaganda. Right? There's just absolutely no evidence that all of these tests are really any kind of rigorous test. So again, just more talk. It's passed all the tests. It's done everything. It's answered all the questions. You didn't answer where the energy came from. So it failed that test. Dismally failed. I don't know what this is doing. I'll skip it. Yeah, it's back. Okay.
More things to try. A well-known and empirically validated finding is that accelerating charges radiate electromagnetic radiation. So one conceptually...
So this is a key part of their theory, that they say this nonsense, that it's like the moon orbiting the Earth, right? Except they say electrons, when they orbit, are excreting energy. And so they can't possibly maintain an orbit because they're somehow losing their velocity because they're excreting this magnetic field thing. And you're saying, you made that up. I mean, there's no evidence any of that takes place. And they use it as an excuse to say, well, the idea of orbiting electrons doesn't work because they would crash, because they would lose their velocity by some magical mechanism. Well, it's all nonsense. But anyway, the very idea of the moving electron anyway was silly. I mean, it's obviously atoms have electrons in real positions, and when they share an electron, it's in a real position. It stays there, and the two atoms, the two nucleuses, literally share it. I mean, it's amazing the nonsense they believe. And again, the reasoning is vacuous. There's nothing to back it up. There's nothing to back up this idea that you must believe that when an electron moves, it creates some sort of energy release. It doesn't.
Simple experimental test would be to compare the behavior of a stationary charge in a gravitational field to a free-falling one. If a more Newtonian picture of gravity is correct, well then the stationary charge should not radiate electromagnetic radiation, but a free-falling one is accelerating and therefore...
So obviously there's very little data they're going to be able to collect from watching single protons or single electrons. So we know this is bogus right on its face. I'd argue that there might be some truth to the fact that electrons aren't moved by gravity and protons are, because all you need is one of the elements to be moved to drag the other elements with it.
It should radiate. In contrast, general relativity sees the free-falling charge as non-accelerating. It's just going on a straight line path through curved spacetime, whereas the stationary charge is accelerating, and therefore it should give off electromagnetic radiation. Now, thus far, logistical challenges have prevented anyone from actually carrying out this experiment.
Right, so he's just talking crap about, magical experiments we frankly are never going to do. There's some experiments you just can't do. You're not going to take a videotape of an electron.
But what you believe will happen reveals what you truly think about the nature of gravity. Do you think that a freely falling charge will radiate electromagnetic radiation or not?
Well, do you think that the force of gravity, the mechanism of gravity, creates impacts, and those impacts have created momentum in them? There's new momentum in the universe because of those impacts. So as long as you concede that gravity causes collisions and that the collisions contain new energy that wouldn't exist without gravity, now you have something to explain. Just explain where the energy goes and explain where the energy came from. Simple enough task.
Is gravity an illusion? This episode...
So that was crap. Alright, so it was sponsored by this warehouse I'm in with my mask and such, because it's COVID or something. Alright, well, too pathetic. So we made it. Yay, we did the whole video. Yay for me. But absolute garbage, especially the Eddington part, just absolute. Let's just lie about the historical facts. Alright, let's see. You have to be so rude. Okay, yeah, I should just block you. What this life? Yeah, who needs you, shithead? His argument next to conventional physics actually more rational. I think his understanding of gravity is much better than space-time. MGH is how it affects a rolling object. Again, you're wrong. It's MGT. I don't know what is this sentence? MGH and how it affects a rolling object. All right, is much better than space-time and, okay, so you should put an and in there. MGH. okay, and then have a colon or something, or a dash dash dash, or a dot dot dot, how it affects a rolling object or something. Yeah, obviously it makes more sense. Obviously it's 9.8 meters, again, I'll say it again, per 1 second. Veritasium in the video said 9.8 meters per second squared. Why is that per second squared, therefore? It's not 9.8 meters per second squared. It's 9.8 meters per second per 1 second. It's in 1 second units. It's a time-dependent force. They can't even get that right. And you bozos are going to tell, you're going to insult me when they say things that incredible. All right, does the difference in heat inside a planet dictate gravity strength, or does, okay, we did that. Okay, I'm not buying time as a dimension. Well, I'm just saying by the logical definition of dimension, the only definition we have, frankly. The only definition of a dimension is that you have a straight line and you have 3 straight line dimensions, okay, describing a space of 180 degrees. And the key feature is they all form right angles to each other at the intersections. There's no other angle except right angles. So you can't have a 4th dimension because there's no way to shove another line in and have right angles to all the other 3. So the very fact that they don't even pay any attention to their own definition of a dimension. Gary, the message about wanting attention wasn't towards you. I was talking to the guy you banned. Can you unban? I don't know if I can. Yeah, how do I do that? Let's see if it works. I'll try that. Let's see. It says hide user still. They used to give me that option. Anyway, it did change, and then you could sit there and change it. Let's see. Maybe if I view the deleted message. No, that didn't work. Let's try that again, though. Let's get rid of this stupid menu. Stop making a menu thing, please. Oh, God, it just keeps doing it. I can't get rid of the menu. Stop it! Stop making that menu thing. God, it won't go away. Alright, there. Got rid of that shit. Alright, let's see. View deleted message. Alright. Yeah, it just says hide user again. Did I put you in a timeout, or did I banned you, huh? Don't remember. I could put you in a 1 minute. Well, I'll put you in a 10-second, right? What's the point of a 10-second timeout? I mean, that's just too ridiculous. Too ridiculous. Well, what I'll try to do is unban you some other way. I have to go to your channel. Can I do that? Go to channel, yeah. Okay. I apologize, but yeah, you get so sick of this horse shit. Alright, so I have to go, where do I go to unban you? I have to go to report user. It doesn't give me the option to unban you, so you must not be banned. Oh, it's probably the wrong channel. Okay, I get it. I can't unban you because I don't have you banned at this channel. I have you banned on the other channel. Oh, this is just such a pain. YouTube just is such a pain in the ass. I wish they would fix my draft science channel. Alright, so I have to open a new tab, put in your channel. Okay, hit enter. Ugh. You can't hit the arrow thing because it never goes where you want it to. Bastards. Okay, report user. Damn it! Alright, you're not banned, apparently. Okay, well, we'll wait and see. I can't unban you because apparently you're not banned. I don't know. It's the way it's turning out. So, sorry, I tried. Didn't happen. Let's see, it wasn't towards you. Okay, so we just have to keep using this other channel, I guess. The Hubble telescope has proven Einstein's relativity from space. So again, didn't prove anything. Free of any obstruction from the effects of the sun. So that's just a lie. The Hubble telescope did not do the Eddington experiment. It just factually didn't. Now, what it has done is shown us some lensing images but they're all preposterously uneven, bent all over the place. I mean, they're not even close to any kind of geometric precision. They're mathematically as ugly as could be, and their excuse is, well, the dark matter makes, it possible. So fuck you. There's no proof, Dr. Bees. You're just such lame assholes. You fall for anything. You're just proving how gullible humans are. You're just religious kooks, bowing at your totem pole. And that's it. Of rubbish and silliness. I'm going to prove it all to be exactly that, because I'm going to model it all. I'm going to show how it all works. And my arguments are going to be so simple. My mechanisms are going to be so simple, 1,000,000 times simpler than anything you've ever conceived of. All right? The universe is incredibly simple. 2 kinds of force, 2 kinds of matter, 3 kinds of interactions. That's it. The entire universe is made out of that. So fuck you. I'm going to rule the day, buddy, and you're going to be on the ash heap of stupid motherfucking asshole who commented irrationally and irrelevantly for living a useless, stupid, retarded life. So good on you, you fucking piece of shit. You're going to be on the ash heap of human garbage. My prediction. It's fine, I'll just use this one. I timed out anyway. Good. Thanks. No worries. Appreciate it, Gary. Okay. Are you opposed to citing these studies? What studies are... What's a study? Did Veritasium cite the studies that prove that the energy created by gravity disappears somewhere? Where's the study showing where it disappears to? Okay. You're referencing to contain the defective lensing images. I'm saying go look at any lensing image. Go look at it, you retard. Show me one. Go find a lensing image and I'll just show you how it's mathematical nonsense. It's not being created by a spherical gravity, and the strong gravity you need to bend light is going to end up being spherical. But regardless, it's got huge inconsistencies. I mean, pieces arcing this way, and then another piece arcs a little bit that way. I mean, they're all over the place. And then they have whole galaxies. I mean, you think Einstein knew what he was talking about, right? Well, Einstein said overtly to you, you will not see an Einstein ring. You won't see rings. Because the gravity... Einstein at least was honest enough to understand what a magnifying lens is and what the opposite of a magnifying lens. And he understood that gravity is the opposite. It bends the light inside the center a whole bunch and bends the light on the outside not at all. So it's exactly the opposite of a magnifying lens. So there's only going to be one tiny shred where the photons are actually going to be bent to you. And as soon as the object moves a little on the inside, it goes the wrong place, it bends out. As soon as it goes a little bit on the outside, it bends to the wrong place, so you don't see it. So it's a tiny shred of photons, so you would never see a galaxy lensed in an image. Clearly, their lensing images have whole galaxies being lensed. So if you think Einstein knew what he was talking about, you'd have to say, well, that's supposed to be impossible, so how did they make that possible? You people are just so, like I said, you're just dupes. I can't help you, okay? You're just a dupe. You believe it because they say so, not because they really showed you so. Fuck you. I don't have to write a book. It's just so stupid. Why don't we go back? Why don't you write it on papyrus? Yeah, or chip it into a rock. Why don't you go find a rock and chisel the story into the rock? You have all this modern technology. You can do all of this amazing stuff. And you're saying, go write a book. Because a book will, when I say, go write a book. When I write, go write a book, you'll somehow see me going, go write a book. You'll see my satire. No, you won't see my satire. You won't see my anger. You won't see this, motherfucker. You won't see a goddamn thing. So why do you need a goddamn fucking book? There's hours of videos and hours of drawings. What the fuck else do you need, you fucking idiot? You're just a technology denier. Oh, let's all go back to the past and, we won't eat our food that's sanitized and we'll die barfing our guts up. Fuck you. You're just such idiots. I mean, you buy a book. Why the fuck I mean, how can you people be this fucking stupid? Go show me the Feynman book and then show me the Feynman lectures, and you go explain to me how the book is so much fucking better. Why don't you do that? Show me the lecture notes from Professor Lewin and then show me the lecture and then explain to me how, oh yes, it's so much easier to understand from the written text than it is the actual demonstrations. God, I just can't stand your stupidity. On every fucking subject, you people are stupid. I mean, it's just stupid. How many books do you think Veritasium would sell? Do you think anybody really gives a shit to read books anymore? What the fuck? I have read, literally, 1,000 books in my life, okay, which isn't maybe that many. And they're stale and dry and boring and tedious, and there's 3 pages of stuff that could be a little bit interesting, and the rest of it is just, oh god damn it, I wish they'd get to a fucking point. I read a fucking Einstein book this fucking thick, and it didn't have any fucking physics in it. Oh, I hate you people. I can't, I shouldn't react, but I mean, I just can't help but being totally stunned that I can't find a reasonable motherfucking human on this planet. There's just not one fucking person that can be smart and reasonable. I mean, there's some that are trying a little bit, but some of you people just don't try at all. I mean, the last 3 videos I've made on the subject of gravity just blow it up. I mean, it's over. You cannot, an mv squared. I mean, it's over. Their theory is dead. The drag simulation is coming any day now. And, and it's just going to prove that, yeah, okay, they just do this offhanded statement. Oh, it causes drag and you can't, things stop moving, blah, blah, blah. Yeah. Just like when they say the electron is losing energy because it's creating a magnetic field and it's working so hard, it's pulling all its levers to make the magnetic field. I mean, it's all such horse shit. I don't care whether you would read one if I wrote one. Guess what? At the website, there's a whole bunch of crap I wrote. So why don't you just go to the website, okay, and there's a part that says something at the bottom there, or some statement about crap they say. And there's a bunch of stuff I already wrote. So go read that if you want to read shit. But I really, I think it's okay the way I wrote it. It sort of explains the shit, but it's not nearly as good as drawings in a video. God damn it. How could somebody have the preference to read it in a fucking book? How could that be your fucking preference? It's ridiculous. I can't imagine it. Like I said, what book should I go out and buy that's going to be so much better than a physics lecture? I have a couple of physics textbooks, and they're incredibly dry. You have to sit there. Sometimes you can't even connect. Whatever little illustrations they have are so undetailed that you really can't get a feel for anything. Nothing's really moving. You can't move anything in the pictures. I mean, it's just terrible. But anyway, I make this whole video, and what do you people do? You want to talk about writing a book? I mean, just shit. Ugh. I just can't stand this planet. Hate it, hate it, hate it. I mean, even just writing a book about how to wax your floor, you can't, it's so much more work, okay, than just showing a 5-minute video of how to wax the floor. I mean, it's like every product they sell that has assembly instructions. Every company that makes a product, they ought to just have a video somewhere that shows how to assemble it. What's the big deal? Try to read the fucking instructions, and it's like, what the fuck are they talking about? Package A, and then package A dash 2. You're like, oh, connect A to A dash 2. I mean, it's terrible. Now, I'm not saying it'd be a waste of time. I'm just saying I don't think it makes me any more understandable. A book wouldn't make anything I'm describing easier to understand. I mean, organizing the content I have in this video, I concede, would be better. I get rid of these conversations, blah, blah, blah. Well, look, I didn't talk to you people while I was making the Veritasium video, so in a sense, it's a legitimate response. I'm taking every point made by Veritasium, and I'm showing where he either doesn't have evidence for that or he's completely ignoring a glaring fact, and it's going to remain a glaring fact. So it's like in the past, people could argue against Lesage gravity because there's this glaring fact that drag makes it break. So if you believe that things can't keep moving when they move into a force, well then obviously, yeah, it's a problem. I can see the problem. Okay. So it's a flaw in a counter theory until you can explain why the flaw is not a problem. It's a flaw. He's evading the flaws. See, everybody else, any opposing theory has to account for its flaws, but they don't have to account for any of their flaws, right? So they're completely unaccountable. They can say shit, and you're not allowed to say shit like, well, the wires are melting, you fucktard. How can the electricity be traveling outside the fucking wire when the wire is fucking melting, you retard? I mean, obviously the electrons have to be doing an awful lot of fucking moving for the wire to fucking melt. But they evade everything. That was his electricity argument. I mean, all his arguments are so bad. I mean, they're so bad for people's brains because they're not true. He's convincing people that of absolute crap. And none of you people are bothered that this asshole, for money is selling a bunch of religion as science. I wonder how many people are in here. Let's see. I mean, YouTube's obviously, it's like they ruin everything, right? So the first 3 or 4 live rooms I did, they got about 350 views. The last 4 I've done got 150. It doesn't make much sense, frankly. So 13. Well, that's not terrible. But the 13 of you need to do a little better. I mean, I think the reason why people don't make response videos is because, it is work. It is work to be able to respond to every sentence somebody says. That takes, you got to know what you're talking about to be able to do that competently. And you can see it when somebody actually plays one of my videos. All the parts where they have no counter argument, they just play it and let it play and let it play for 4 minutes of me talking, and they don't respond at all. because they can't respond. They can't answer my points. And they just wait till I make some kind of verbal error or something to jump in. Yeah, well, that's okay. I'm sorry you're not a science guy, so I'm just saying, science is the road to any kind of philosophical conclusion. You have to have the science right. You have to have your understanding of the foundation right, or you can't do any of the other shit, reasonably, in my opinion. So you can't do the do not God thing unless you know what geology is, and you know that the Earth has to be billions of years old, and you know all of this other stuff that makes the God story silly. I mean, good science destroys fables. But unfortunately, science isn't doing good science. Physicists, in particular, are not doing good science. They're just making crap up. Silly crap. They're just doing a bunch of girly physics. Alright, so I should... Well, the least I can do is put the image back up. Yeah, put that back up. Yeah. I'll have to make that the icon. Yes, Veritasium is brain poison. Excellent. Message retracted. Oh, okay. Interesting. Maybe I'll try again. Oh, maybe. Or maybe not. Yeah, I wish I understood science better. Your DNG videos convey the message very well either way. Yeah, well, I'm just saying, you should be able to say to yourself that you have acquired some understanding of the basic idea of push and pull, and then the idea of collision, the idea of momentum. I mean, I'm just saying it really is that simple. So I'm just saying that in a way, it's a huge shortcut I'm giving you by just pointing out that all you really have to be able to understand is the two force thing and the two matter thing, and the fact that they have that third interaction where the electron force turns into a proton force, and the proton force turns into an electron force. And that really explains everything, because it explains why electrons repel electrons and why protons attract or crash into protons. Yeah, well, school was a weird thing, I gotta say, just because, they really didn't make any... Again, they didn't tie things together. They drew that wavy crap, photon-y thing, and then you do a cloud chamber experiment. You watch the radiation shooting off in straight lines, and you say, what is this wavy crap? Why are we having a conversation about this wavy crap? I mean, so many subjects are just so... I mean, the whole aperture thing, I mean, it's just so obvious. You make the aperture smaller and smaller, and all of a sudden you get more and more fringes. You just say more and more of the photons, a higher percentage of the photons start fringing. And it's like, well, I guess it's the fact that the photons, what's happening? Well, the odds of hitting the surface are going up. It just seems so obvious that, oh yeah, it's the surface that's causing it. Duh. But like I say, I guess all that I can say that I'm disappointed to learn, because I didn't think it was true, is that somehow there is some sort of, mankind has a boner for religion. There's some sort of, genetic boner for the silliest and the goofiest stories possible. Give me that crap. I mean, humans are poo eaters, it turns out. They'll just eat pooey fables all day long. And the truth, they can't go near it. I mean, they really do. I mean, the human race really does deserve to be eaten by aliens. They're just... they're just mushy bugs. They've disgraced their 100 billion neuron-strong brains. You've just disgraced your intelligence. That's all people do, is disgracefully abuse their ability to think. I'd imagine that mostly stems from ignorance, mostly stems, I guess. Stems, sorry. Yeah, I can't see too well. From ignorance and fear of the indifferent void will grasp onto any bullshit. Yeah, I mean, that seems like a weak statement in so many ways. But because there's so many ghouls, in the human race, there's so many people that are, they'll watch, horrible things happen to things, and they enjoy it, and they enjoy risk and, so it's more of a stupid gene, I think. I don't know what to think. I don't know. It's just, it's hard to say. I guess they just don't want us, yeah, it's really hard. I don't know what it is. I mean, it's some kind of masochistic thing. Well, it's more like I said, this thing, right? Because they like watching failure as long as it's not their failure. I mean, it'd be nice to say, okay, yes, they're scared of the void, but they show no fear at all of cancer and horrible death. They're almost like in love with it. Right? I mean, like the St. Jude commercials. Oh, it's fun to have cancer. It's balloons and teddy bears and fun. Yeah. Creeps me the fuck out. I mean, in so many ways, yes, it's always been an upside-down world I've had to live in. Can't relate, can't fit in, can't make sense of it. All the pointless waste. Yep, just part of the tragedy of existence. The agony and the agony. So little ecstasy, just a little tiny drivel of ecstasy. It's like a little sandwich with giant thick hunks of agony and little tiny little spread of ecstasy. It's just all the ignorant. I mean, it's just, the bad apples are all just ignorant apples, And as the commercials indicate, ignorance is now the new intelligence. It's just, just disgusting. Cultural backsliding. Alright, so things are a little slow. I really don't want to play another video. I'm a little tired, don't want to draw too much, but let's see. What could I draw that's simple? And related to the subject, of course. So again, the simple argument is that gravity causes an event. Things that would not bother with each other are going to bother with each other. So things that would, even if they had a velocity, they would just keep their little silly velocities and do their thing, and that's it. But gravity is going to cause them to crash into each other, and they're going to crash into each other, even if you say both objects are moving, at some point, and at that point of intersection, there will be a release of energy, just an absolute fact. So, absolute fact that energy will be released at the point of the collision. So somewhere that energy came from something, and they don't have any account for some energy doing that. So my theory is that obviously the heat created by gravity radiates out into the universe, and essentially it's the same heat that's pushing things into the object. So it's circular. So all of the objects burning in the sky, all of the stuff that's radiating photons of all variety, is the pressure in the universe, and the pressure is just delayed going through the earth. So the force that would compensate for your mass coming from below doesn't get to you now. And the very fact is it has to get to you now to keep you from falling. If it doesn't get to you now, you're going to fall. So it has to get to you now, and it doesn't get to you now. It'll leak out of the earth later, so if I kill the gravity, the residual heat in the earth will keep pushing up, and it would push me. So if I could turn off gravity, I would get pushed, really fast, okay, by the pressure inside of the earth, the heat. Pushed really fast. So there's a whole bunch of it in there that wants to push me back up, but it just can't get there now. Okay, so that's the key thing missing. So all the stuff is just doing this. This is the perpetual engine, the only one that exists in nature. It's all conserved, and the only thing that it changes, ironically, is time. So this is the only way to understand time. Time is about delaying something. And if you delay something, you've changed the universe, because now you've changed the balance of the pushes. So the balance would be there if it wasn't the delay of going and moving the matter. Moving the matter delays the force. The force can't show up to push back, so the object falls. It gains momentum. And then the momentum causes big giant pile of energy to be released. That's the rational explanation. And their silly explanation doesn't have anything. So there's no this. This doesn't exist in their silly theory, right? There's no source of the momentum. So you have a big MV experience, right? A big momentum collision. Lots of discrete bits flying off, lots of stuff happening, lots of energy in the universe, and they don't account for any of it. So you have the explosion creating lots of energy, then you have the mass itself sitting on the Earth, constantly pushing in, creating more and more pressure inside the Earth. They don't account for any of that. So they account for nothing. So Veritasium did a video about, what do we get from the sun? And he talked about the energy coming in and the energy coming out. And he didn't talk at all about gravity heating the Earth, nothing. And it's just it's a key component of the function of the Earth is the fact that it's got all that pressure on the inside. It's a key fact of its existence. And they don't have any rational theory. I mean, they're telling you that there's uranium inside the center of the Earth that's burning. And it essentially burns, right? You're burning the uranium. You're breaking it up. And you can't use it once it's broken. You can't use it again. So the fact is that, it has half-lives of 10,000 years. How could it be uranium? For 2 billion years, uranium's been heating the Earth? I mean, it's nonsense. And they talk about, previous collisions 4 billion years ago. Well, there's no evidence the Earth has a vacuum layer or any kind of insulating layer, and even a vacuum layer isn't insulation. So there's nothing to contain or hold or keep the pressure. As soon as you release it, as soon as I take the gravity away, the whole thing explodes. So, their theory absolutely sucks. It has no... one of the most elemental parts of physics is understanding the conservation of energy, and they have no conservation in their theory. And then they'll tell you there's this entropy problem where the whole universe is getting colder and colder and colder, and there's just complete denial that every time something falls in gravity, it's getting hotter and hotter. How could it be getting colder and colder if it's getting hotter and hotter? And you dupes all fall for their crap bullshit theories, and it doesn't make any logical sense at all. It doesn't fit with any understanding. I mean, really, how can you people be obnoxious to the Descartesian notion that the energy constantly moves, that there's no new sources? It's just the same energy just keeps moving from one object to another object, 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 to another object. That's all that can happen. How can you deny the logic of that? I mean, it just amazes me that I have to aggressively make these arguments for literally years, and I get nothing but crap as a response from people. And it is, pretty much literally just crap. yeah, it really is. It's horrible crap. All right, so nobody said anything for a good 5 minutes, so I guess we're done. Unfortunately. I mean, I feel like being provoked into saying something, but it's just, I don't feel like doing both parts of the conversation. I really just don't feel like having to do all the work. Ask the questions and answer the questions. Yeah, I mean, come on. I shouldn't have to do everything. Where the hell's my mouse? I can't leave until I find my mouse. How the hell did I lose it? Interesting. It's got a cord on it. It's not like it's that easy to lose. How the hell did I lose the mouse? Yeah, very interesting. Ah, there it is, way over there. Yeah, okay. I really have to clean my desk so I can actually have the keyboard and the mouse on the desk. That would be the logical thing to do. But I have the little whiteboard here, so it's on the desk. And, so I have a continuity problem. Well, and also the other computer broke, and so I had the keyboard on top of the computer, which was kind of convenient because it was high enough, but now the computer's gone, and so the other computer is running. So maybe I should just move the other computer over here. But it's a little louder, so if I move it over here, then the mic's going to pick it up. Alright. So many things to consider. Yeah, it's just life is just not simple enough. Alright, so I'll erase and then I'll leave. Something like that. But it is kind of weird, right? Because, I could, you take these magnets, for example, right? And then people can understand, that this isn't a bent geodesic, right? A bent geodesic doesn't cause this crap, right? Yeah, so it's not a bent geodesic that causes that to happen. I wonder if maybe this is stronger, so if I put one out here. So, see, they're sticking to the board, which is it's a metal board, so that's why it's ruining my experiment. Yeah, I need to have it on something that's not, doesn't stick to. Well, anyway, but you get my point, right? They don't say magnetism is a bent geodesic. They recognize that it's real momentum. It's got to be some kind of real mechanism, real force, So how come that's not a bent geodesic? It's exactly the same damn thing, right? So why isn't that a bent geodesic? It's creating motion, causing a collision, making energy, making pieces fly off, all that kind of stuff. It's doing all that. Why isn't that a bent geodesic? Why is the force of magnetism not in the same category as the force of gravity? I mean, clearly the attraction part is the same. The repulsion part's different, but I mean the attraction part's exactly the same. Inverse square law, all that crap. Now, if you use a whole magnet, then it's more like a R cubed rule. But they've never proven it, which is funny. They just say, well, it's sort of an R cubed rule. I guess it's worth me explaining that a little bit. So the obvious reason why it's an R cubed rule is because of dilution. So if you had a two charges connected to each other, you could sort of understand that individually, okay, they're doing the R squared rule, right? So individually they're sending radiation away, spreading this way and spreading that way. So you have to understand that as a three-dimensional drawing. So the radiation is not only spreading this way, it's spreading up and down, right? And so individually they have an R squared rule. But when you mix them, the problem becomes they're going to cause the opposite effect. And so as you go out, it's starting to turn purple, right? And the purple is, I don't know how to draw purple exactly. Maybe I can just do it this way. All right, yeah, that's a little purple. Yeah, now the pen will be ruined. So it's creating purple. So it's creating ambiguous, right? Because it's not that purple won't attract an electron, and it won't attract it won't do anything. So that's why it becomes an ambiguous cubed rule, because the further away you go, the more purple it's going to get. And so in a sense, you're diminishing any possibility of one or the other forces, having an effect, because it's all purple, right? So if I'm over here, it won't be as purple because I'm getting more red than I am blue. And if I'm over here, it's not going to be as purple. But, yeah. So that's why it's sort of ambiguous, because it really depends on, where you test the dipole. If you test it here, obviously it's not going to be purple at all. And if you test it here, it's not going to be purple at all. So it really, it's a more complicated question because it's only getting purple in one place, and everywhere else it's, less purple or not purple at all. But it is funny that physics just doesn't even talk about that. I mean, it doesn't really talk about dipoles and the field they create. There's just no literature that pays any attention. It's obviously becomes frickin' magnetism is what you're talking about, and they just don't have any rational explanation for how magnets work. Magnets don't generate force. It just goes through them and it bounces off of them, but that's all that happens. Magnets don't make energy. They just reflect it or transmit it. Same difference. They don't make anything new. They just take what's coming into them and filter it. Good night, chat. Okay, so the only person talking is leaving. So, yeah, see you next time and such. Yeah, there's only 8 people in here now, so, yeah, it's really view numbers are way down. But that's fine. I mean, it's the way it is. Tough shit and such. So, it's probably a good note to leave on. So, till the next time and such, did my job again, as always. And, we'll see if any of you can do your job. So if you are a science competent person, that is, you've spent some time acquiring this knowledge of how things work, please explain where I said something catastrophically in error, that you can provide some sort of evidence that what I claim to be a more reasonable explanation is in fact not more reasonable, or some drawing that doesn't describe the actual reality. Please. Yeah, somebody respond with a physics argument. That would be really interesting. Something scientifically credible besides just statements regarding your belief in bullshit. Alright, anyway, so till the next time and such and so forth and whatnot.